In this video, I'll talk about the basic number system. There are different kinds of sets of numbers, and the first set I'm going to talk about has those numbers which are everybody's the very first numbers, and those numbers are 1, 2, 3, 4 up to so on. And if I write these numbers in a set notation, then this set is called the set of natural numbers. It has numbers 1, 2, 3, 4, 5 up to so on. There are infinite numbers in this set, and this set can be written as n/. Now here you see I have used this slash along with n. Now why didn't I just write n instead of n/? Now, this n/ is a set of natural numbers, but this n can be anything accordingly what we define. So if I write n equals to 1, 2, 3 up to so on, then this n is a set of natural numbers. But if I write n as, let's say, 2, 4, 6, then this n is a set which has three numbers 2, 4 and 6. Let's say I write it as 2, 4, 6, 8 up to so on. That is all the even numbers. Now here this set is a set of all the even numbers. Or let's say this is a triangle and this is a vertex n. Now here this n is a vertex of this triangle. So this is a triangle MNO and n is one of the vertices of this triangle. So this n can be anything according to what we define, but this n is a set of natural numbers wherever I use it, like that. So when I use n/, I don't need to define it like this. I can just use n/, then this will be a set of natural numbers. But if I use this n, I have to define it what it is. So I have used here n/. You can put this slash over here, or you can put this slash over here. Now the next set is the set of whole numbers. And it has the numbers 1, 2, 3, 4 up to so on, all the natural numbers and 0. Now this is a set of whole numbers, and I write it as w/. Now you see all the natural numbers are in the set of whole numbers also. So natural numbers is a subset of whole numbers. Now our next set is the set of integers. Integers, and it's written as z/, and it has the numbers, first of all the whole numbers 1, 0, 1, 2, 3 up to so on, and negative numbers, -1, -2, -3 up to so on. This is a set of integers. Now the next set is a set of rational numbers. And this set has numbers which can be written in the form of P over Q, where P and Q both are integers. That means if I pick any two numbers from this set and I write it in this form, then that number will be a rational number. These numbers are integers, provided the denominator cannot be 0. That means q cannot be 0. Otherwise this value will be undefined. So what are rational numbers? If I pick any two numbers from the set of integers and I write it in the form of p over q, where q is not equal to 0, then that number will be a rational number. Let's see some examples. Pick any two numbers from this set. Let's say I pick 2 and minus 1. So 2 divided by minus 1, this is a rational number. Next, let's say 3 and 1. 3 divided by 1 is a rational number, or 1 divided by 3 is a rational number. Let's say minus 2 divided by minus 3. Now this is a rational number, which is basically 2 by 3. This is a rational number. Or let's say 0 and 3. So 0 divided by 3. This is a rational number, which is 0 only. Next, any number you can pick from this set. So let's say I picked 100 over 3. This is a rational number. Or minus 99 over 50. This is a rational number. So these all are the examples of rational numbers. Any number you can write in the form of p over q, where these both numbers are picked from the set of integers, where the denominator is not equal to 0. Then that number will be the rational number, and we write it as q slash. This is a set of rational numbers. Now here you see all the natural numbers is a subset of whole numbers. All the whole numbers, that means the set of whole numbers, is a subset of integers, and integers is a subset of rational numbers. Now our next set is the set of irrational numbers. Irrational numbers. And the irrational numbers are the numbers, I'll first define it. The numbers which are not rational, non-terminating, and non-repeating. This is the definition for irrational numbers. The numbers which are not rational numbers, and it has to be non-terminating and non-repeating. Now what does non-terminating and non-repeating means? Now a decimal number, if I take some decimal number, let's say 0.234. Now this is a decimal number and this is a terminating decimal number. So if I write a decimal number, let's say 0.23456900134, and it's keep on going. Now this is a decimal number which is non-terminating. So then this number is an irrational number, and this is a rational number. Let's take one more example. 1.562315394875. Let's keep on going. This is an irrational number. Or if you take root 2 is equal to 1.414. If you calculate this number by using a calculator, you will see that this is a non-terminating decimal number. It's 1.414213, and it's keep on going like that. So this root 2 is an irrational number. Like that, there is a number pi. You might have heard about it. So this is equal to 3.14. This is also a non-terminating number, so it's a irrational number. Like there is an exponential number e which is equal to 2.718 and so on. So this is also a non-terminating number, so it's an irrational number. So these all are the examples of irrational numbers. So any number which is not rational and which is non-terminating and non-repeating, those are irrational numbers. Now non-repeating means a number cannot be written as 4, 5, 5, let's say bar. Now this is a repeating number. The decimals are repeating here. It means we can write it as 0.45555 and there are infinite 5s. Now this 5 is repeating, so that means it is a rational number, not irrational number. Now why this number cannot be an irrational number? Let's see. Let's take a rational number 1/3. Now it's a rational number and I can write it as 0.33. If you divide it, you get 0.333 and so on. And you can write it as 0.3 bar for repeating 3's. Now that's why a repeating number cannot be an irrational number, because it is a rational number. So these are the examples of irrational numbers. Now our next set is the set of real numbers. Now what are real numbers? Real numbers. Now so far we have done natural numbers, whole numbers, integers, rational numbers and irrational numbers. Now real numbers are the numbers which are all the numbers we did in the previous page. Or you can write it as a union of rational numbers and irrational numbers. I guess I forgot to tell that irrational numbers are written as I/. So this is a notation for irrational numbers. This is a set of irrational numbers. Now, what are real numbers? The union of rational numbers and irrational numbers. Rational numbers and irrational numbers. Those are all real numbers. Now let's draw a number line. Let's say this is a number line. Now I'll take the middle, 0, 1, 2 up to so on, and -1, -2 up to so on. Now we'll see how do we see all these numbers we did on this number line, and the real numbers are written as R/. This is a notation for real numbers. Now first we did natural numbers. Those numbers are 1, 2, here 3, 4 up to so on, these dotted points. These are the natural numbers. Now next set was whole numbers. So 0, 1, 2, 3, 4 up to so on, these are whole numbers. The next set is integers. Those numbers are 0, 1, 2, 3 up to so on, and from this side -1, -2 up to so on. Now all these dotted numbers are integers on this number line. Now next set is rational numbers. Now what are rational numbers? A number which can be written in the form of P over Q, where P and Q are integers and Q cannot be 0. Those are rational numbers. So where do we find these numbers on this number line? So let's say this is the half of 0 and 1. So this is number 1 by 2, right? So here somewhere will be the number 1 by 3. 1 by 3. Like that, here will be 1 by 4, 1 by 5, 1 by 6, and it will keep on going like that. So between 0 and 1 there are infinite rational numbers. That means, and between 1 and 2 there will be infinite many rational numbers between these 2 points. So you will find all these rational numbers on this number line. And the next set was irrational numbers, right? So where do we find irrational numbers on this number line? So I gave you an example of irrational number, root 2, which is equal to 1.414 and so on. So now let me write it here, 1.414. Now this number is bigger than 1.4, right, and smaller than 1.5, right? And these are rational numbers, but this number root 2 is an irrational number. So first let's see where is 1.4 and 1.5 on this number line. So 1.5 will be here, this number 1.5, and 1.4 will be here left to it. So here this is 1.4. So this number root 2 will be between here somewhere, right? Root 2. Or let's see one more number. Let's see between 2 and 3. So I'll take a number 2.6 and 2.7 between 2 and 3. They will be here somewhere, right? So I'll pick a number between 2.6 and 2.7, which can be 2.6, 1, 3, 4, 2, 5, 7, 9, 3, 4, 3, 1, 2, and so on. Now this is an irrational number because it's non-terminating and it's between 2.6 and 2.7. So this irrational number is here somewhere. Here. So this is how we locate irrational numbers on this number line. So there will be infinite rational numbers, infinite irrational numbers, integer, whole numbers, and natural numbers. All the numbers are infinite on this number line, and all these numbers together form the set of real numbers. That means each number on this number line is a real number. So that's why this number line is called a real number line. Now our next set is a set of complex numbers. Complex numbers. What are complex numbers? Now complex numbers are the numbers which can be written in the form of, let's say, I'll write some examples. 2 plus 3 iota. This is called iota. I'll write it. iota, which is equal to root -1. So if a number can be written as any number over here, so I wrote 2 plus any number over here, 3 iota. This is fixed iota. So I'll write one more example, 5 plus 6 iota. So at these places I can write any two real numbers. And if I write a number using two real numbers as this, then that number will be a complex number. So let's write more numbers. Let's say 2 minus 5 iota, or -2 minus 3 iota, or -1 plus 2 iota, or I can write it as or I can take 3 iota, because I can write it as 0 plus 3 iota, or 3 is also a complex number, because 3 can be written as 3 plus 0 iota. So all these are the examples of complex numbers. Now I represented all the real numbers on this number line. So where do I find these complex numbers? Where do these live? So this is a real number line. Now if I make one more imaginary number line like this, then this is called a plane, and we say this x-axis and this y-axis. Then these numbers can be found on this plane. Now how do I find these numbers? So first I'll write numbers 1, 2, 3, 4 and so on. This side -1, -2, -3, -4 and so on. And here 1, 2, 3, here -1, -2, -3 and so on. Now I have to find 2 plus 3 iota on this plane. So how do I find? Now this number without iota represent the number of x-axis, and this number represent the number of y-axis. That means this is a number from real number line and this is a number from imaginary number line. This is a real part and this is the imaginary part. So 2 is from the real number line, that is x-axis. So this point, and on y-axis the point is 3. So I have to take the point at the intersection. That means this point. So this point is the point 2 plus 3 iota. Let's find this point on this plane. So -1. So -1 is here and +2, it's here. So this point is -1 plus 2 iota. So that's how we find these complex number on the plane. And the notation for complex number is C/. So which number sets we did today? A set of natural number, a set of whole numbers, integers, rationals, irrationals, reals and complex. So this is our whole number system. If you like this video, don't forget to subscribe.